Okay, I hope the first one is pretty simple for you. It says a system of equations is, and you would know because 2 weeks in a row you've had to answer this question. So what is it?
Two or more equations that share something.
2 or more equations that share a common solution. There you go. So that's the first answer, right? And we have written this like 2 weeks in a row, so I'm thinking this is actually a free point on the test, right, or the quiz. Okay, the common solution, if we're doing the graphing method, looks like this. Where is the common solution? Right where they intersect. Okay, there it is. Okay, now, systems of equations can be solved using several methods. The first one we learned is called the
Elimination.
No, that's not the first one.
Graphing.
Graphing. Okay, we learned the graphing method right off the bat 2 weeks ago, and it looked kind of like that. We graphed a line, we found the intersection. Okay? First bullet says this. In the graphing method, if the slopes of the lines are different, look, different, that'd be the slope, a line going this way and a line going this way. Different slopes. What are they going to do? They're going to intersect, but listen to this. The lines will intersect in how many points? 1. Okay, 1. 1 point, and the system is classified as, what'd you put? Independent. Guys, we've done this for 3 weeks now. This should be so easy for you. Don't get this wrong on week 3. Now, week 1, if you got it wrong, I understand. Week 2, should have got it right last week. And now this is week 3. Don't get these wrong, okay? If the slopes of the lines are exactly the same, the lines will intersect in how many points?
No.
No points. They won't intersect. Okay, no points. And the system is classified as? Inconsistent. And it looks like this, and it looks like this. Just draw yourself a picture. That's what it looks like. Okay? All right. We're kind of flying through this. Hopefully this is all review for you. In bullet number 3, if the slopes and the y-intercepts of the lines are the same slope, same y-intercept, the lines are what? The lines are the same. Same line on, and they lie on top of each other. So, and the system is classified as dependent. Got it. And if you drew a picture, there's one line. Where's the other line? Right on top. Touches everywhere, right? That's. And by the way, what would be the answer to that system? The answer. IMS. Infinitely many solutions, okay? What about this system? What's the answer?
Infinite many, or no?
This one?
No solution.
I didn't mean to say
Yeah, there's no answer. No answer to this one, right? No solution. What about this one up here? There's one answer. Like, give me an example.
5-4.
5-4. Okay, there you go. 5-4. See, these are the kind of answers you get in solving systems. You get an answer, 5-4. But you don't get any answers. Or you get infinitely many answers. Okay? All right. Got it? That was the graphing method. Now, keep going. The second method we learned is called, this was last week.
Substitution.
Substitution. Good. Substitution method. Okay, there's the first blank, right? These are the steps we use. Step number 1, what was the first thing we did? Blank one variable from either of the equations.
Pick or solve.
Say that again.
Pick or solve.
Pick one variable from either of the equations. Pick one variable, then solve. You can write that. I'm just going to write this word. I'm just going to say solve. solve, and I'm gonna even write solve for. Solve for one variable from either of the equations. Remember last week I said, what do you want to solve for? X or Y. Okay, once you did that, remember doing that? You got something like this. X equals 2y minus 10. You circled it and called it what?
Home.
You called it home. Okay, then once you got to that point, step 2. Blank the expression. Hey, that's the expression. Blank the expression into the blank equation in place of the isolated variable.
Substitute the expression.
Okay, take that expression, 2y plus 10. Substitute the expression right there into the,
Not home equation. Second.
okay, second equation. You can say second equation, or you could say the other equation, right? Because you guys, you solved one equation for x, now substitute that into the other equation, or the second equation, okay? In the place of the isolated variable. Step 3, blank the equation. Solve. If all that's left is y, solve for y. If all that's left is x, solve for x, okay? Step 4, once you solve and you get x equals 10, listen. No, let's say y equals 10. What would you do with y equals 10 after you solve? You go where? Wouldn't you go back home? Yeah, okay, so step 4, blank the value of the first variable into blank of the original equations to solve for the second variable. Plug. Okay. You can use the word plug. I was going to use the word substitute, but plug works. Plug the value of the first variable into what? Home. This is what you and I did. We got y to be 10. So what did? We took 10, we plugged it into home to get the other variable, right? Of the original equations to solve for the second variable. Number 5, write the answer as. How do you write your answer? That's how you write your answer. What's that called? Write your answer as a
Point.
Specific point.
a point. That's a point, yeah. Well, what do we call that when we put numbers here and here?
X, Y.
As
Ordered pair.
an ordered pair, right. Like 10, comma, 3, like that. Write your answer as an ordered pair point, and what do you do once you're done? Check it. There you go. Check. Good. That is nothing but what we did week 1 and week 2, and now we're on week 3. Here's week 3. You ready? Today, we are learning the another method to solve a system. What's it called?
Elimination.
The elimination method. What's the objective today? Get the coefficients on either x or y, doesn't matter, terms to be additive opposites. Okay. What's an additive opposite? So if this is 6x, what do you think I want to be underneath it? It's additive opposite. So what can I add and it would be opposite? Exactly. That's your goal today. You want a 6x on top of a negative 6x. Or a 12y on top of what? Negative 12y. This is your what today? Your goal. Because what are you going to do when you add these together? You're going to get what?
0.
You know what you just did? You eliminated the y term. You eliminated the x term. Guess why they call this the elimination method?
Because you eliminate.
Because you eliminate. You knock it out. That's why. Okay. Now, here are the steps to do elimination. I'm not going to read these to you. Because you're just going to do what?
Ignore them.
You're going to ignore me, you're going to ignore them, and you're not going to listen. And then you're going to wait and wait and wait until I start. Well, let's get started. Let's not even read them. We'll come back and read them later, not today. Okay? Example 1. Here we go. Here's example 1. It says 2x plus 3y equals 7. And it says negative 2x plus 5y equals what? 1. What was the goal?
Get rid of one of the variables.
You want to get rid of, eliminate one of the variables. Well, how about the x terms? Are they opposites?
Yeah.
So if we already met our goal, isn't that our goal? To get opposites? Hey guys, we did it. We're there. So you know what you do? You just draw a line underneath the whole thing, and then you put a little plus sign out here. You don't have to put the plus sign, but it tells you what to do. Now, are you allowed to do this in math? Can you add two equations?
Oh, yeah.
Well, let's take a look. Ready?
We're doing it right now.
Do you agree? Well, but are you allowed to do that?
Probably not.
Is that an equation? Is this true, guys?
Yeah.
Yeah. Let me give you another equation. How about 5 equals 5? Is that true?
Yeah.
Yeah. So are you allowed to add the two equations? Will it still work?
Yeah.
4 plus 5. 4 plus 5. Woohoo! It works. Right? I can do it. So let's do it. All right, ready? Let's add. Well, it's positive 2x plus negative 2x.
0.
Gone. I'm going to write the word out. But Andrew's right. It is 0. So I should put 0, but I'm not going to. Okay, it's just gone. Okay, what's 3y plus 5y? It's 8y. And of course, this plus this is what? 8. Are you smiling? Are you thinking, geez, this is easy. I like this method.
So we do next.
Now what? What do you do?
Divide by 8.
Divide by 8. Divide by 8. And you got what? Y is 1. Hey. I already know. The two lines intersect at something, comma, 1. Right? Okay. How do you get the x value? Plug it in. Where are you going to plug it in, though, Jack?
Any of them?
You got a y here, and you have a y here. So which one? Doesn't matter. Remember, it's supposed to work in both of these. So you just pick one of the original equations and just put it in. Now, I try to pick something with small numbers, and I try to pick something that's positive. I don't like negatives. So which equation would you like me to go with? Top or bottom? Top? Okay, I would do top. Okay, so, hey, would it work if I went in the bottom? Yeah, it's going to work. Okay, so here I go. Can I get rid of this? I think you guys trust me, don't you? Here we go. I'm going to the bottom. Oh, no, I'm going to the top. I said 2x plus 3y equals 7. But what's y?
8.
No, y is 1. Okay, so here I go. 2x plus what? 3 equals 7. Subtract 3. Subtract 3. You get 2x equals 4. X equals 2. Which means they intersect where? 2, 1. So 2 weeks ago, you and I did this problem, and we did this. We graphed a line, and we said, where do they intersect? And you said, right there at 2, 1. That's what you said 2 weeks ago when you did the graphing method. Then last week you did the substitution method. This week it's called the elimination. Was this problem considered easy?
Yes.
Why?
This is already done.
I already had what? I had opposites, and if I have opposites, it's the easiest problem I can give you. Easiest. So when isn't it easy?
When you don't have opposites.
Such as example 2. Okay, go to example 2 now. Okay, example 2 looks like this. X plus 2y equals negative 1, and x minus y equals 8. All right. Do you see the problem?
Should we times the equation by 2?
Okay, so you see the problem, right? This is 1x, this is 1x, that's not opposite. This is 2y, this is negative 1y, those aren't opposites. Okay, but Gabe said what?
Times the bottom one by 2.
He says multiply the bottom one by 2, but hang on. Are you allowed to do that?
I think whatever you gotta do to one, you gotta do to the other.
So would you agree that this is true, right? 6 equals 6. Gabe's trying to tell me, go ahead, multiply both sides by whatever. It doesn't even matter. Pick a number. 3. Is this still true? Yeah, 18 equals what? Hey, it's still true. So yes, you can pick a number and multiply. Now, Gabe, you want what? 2. 2 times what? Top or bottom?
Bottom.
Okay, he says multiply the bottom by 2. Why would that work? Yeah, you're going to get negative 2y on below a positive 2y. So 2 does work. Okay? 2 is okay. If you do that, you get 2x, you get minus 2y, and you get 16. Correct? Okay, now guys, what I don't want you to look at anymore is equation 1. 1, 2, 3. Which one? Don't look at which one? 2. You don't want the middle one because you changed the middle one to look like the third one. So if you could do this with your pencil, go like this. Cross that out. You don't want to look at it anymore. All you're looking at is equation 1, not equation 2, and equation 3. So these are the 2 you're looking at. Draw your line. And now eliminate the x's or the y's. Well, your y's are going to go out, right? Up with the y's. What do the x's add up to? Yeah, this is 1x plus, I'll put a plus sign here, plus 2x makes 3x. And then nothing for y's. And then this makes what, guys? 15. 3x equals 15. Divide by 3. 3. X is 5. Right? Okay. Your job is to go find the other variable, that'd be y. Where do you put the 5? This x. You could even go back to this x if you wanted to. You could go to this x up here. I don't care where you go. But I would, if I were you, I would go back to the originals because the originals were given to you. I know they're correct. What if you multiplied wrong? If you multiplied wrong, 2x minus 2y equals 16, if that's wrong, you're going to get the wrong answer. So would you like to go to the top or the second one? Top? Okay. I'm going to the top because you told me to. Okay, here we go. X plus 2y equals negative 1, but x is what? 5. 5 plus 2y equals negative 1. Minus 5, thank you. And you get 2y equals negative 6, yep. Divide both sides by 2. And you get to negative 3. 5 comma negative 3 is the solution. I will write that right here. 5 for x, negative 3 for y, and there is the intersection point. Good? Okay. It got a little harder, and it just gets harder and harder as we go. So turn it over, see what happens. All right. Do you see your problem? You don't have opposites. So here's what you have. You have a 3x on top of a 2x, or you have a 4y on top of a 3y, and you have to decide right now, what variable do you want to eliminate? He says x's. Could I pick on the y's? Yeah, I could pick on the y's. It's up to you. Now here's the deal. Since Andrew talked first, I'm gonna ask Andrew. Andrew, what would you make both of these?
6x.
6x and no
Negatives.
negative 6. You want one to be 6x and one to be negative 6. Okay, hang on. What if I want to pick on the y's? What are you gonna make them?
12y.
12y on top and negative 12y on the bottom. But you can't pick both of them. You just pick one or the other. Who wants x's? Raise your hand. No, most of you want it. Let's do it. Okay, Andrew, how do I make this one 6x? Times it by 2, he says. And he's right. 2 times this, and 2 times 10 is going to be, I'll write it over here, 6x plus what? Equals what? 20. Okay. Now, make the bottom one negative 6x. That's your goal. But you'd have to multiply by what? Negative 3, right. Good? And that would make a negative 6x. That would make a negative 9y. Equals what? Yep. Draw your line. Add the two equations. Knock out the x's and solve it. All right. You're on your own. Go get it. That was the hardest part of the problem.
Is it
What'd you
negative?
get?
It's like negative.
Well, if you divide by negative 1 and divide by negative 1, negative 1 divided by negative 1 is positive. And then usually you write it as an order.
We're just adding these. Right?
Yep, you add the two equations, which eliminates one of the variables, right? Out with the x's, they're gone. What did the y terms add up to? 8y. Take away 9y. Make what y?
Negative 1.
Negative 1y. And 20. Take away negative 21.
Negative 1.
Negative 1. Negative y equals negative 1. But you want positive 1. Only way to get rid of the multiplier. Do a little quick division and you get what?
1.
There you go. Y is 1. Okay? Which means your answer looks like this, right? Okay. Put the 1 where? Here's the y. Here we go. I see y here. I see y here. I even see y's here. And I see y's here. I'm like, I got 4 y's to pick from. Which y is the best y?
The original.
One of the originals. Which original did you go with?
The top one.
Top one? Okay. 3x plus 4 times y equals 10, and y is 1. 3x, this is plus 4 equals 10. Move the 4 over. Three x equals what? 6. Divide by 3. Knocks out the 3's. And you get x equals what?
2.
2. Answer? 2, 1. If you go back 3 weeks ago, not 3 weeks, 2 weeks ago, you guys graphed the line, and you said what? The answer is 2, 1. I'm not making a graph. I'm trying to get you to do the elimination method now. All okay? Next. Example what? 4. Okay? All right. Do you see a slight problem on this one? Problem being what? The x and the y's are not on the same side. Doesn't have to be. Hey, did you hear me? He says x and y have to be on the same side. He is right, but it doesn't have to be. This equation's in what form? Slope-intercept form. This equation's in what form? Standard. Now, you either put them both in standard form, or you put them both in slope-intercept form. I don't care. But the last, 3 problems we did, haven't they always been in standard forms? So let's just keep it in standard. So this one, we're not going to change it. 3x plus what? Equals 6. Okay, there you go. This one, let's change it. How do you get the x and the y on the same side and the 4 on the other side? Okay, add x. Yeah, if you guys push this x over here, if you just add x and you add x, this cancels out, and now you get x plus y equals what? There you go. So the reason that problem might have been hard is because they weren't in the same form. If I were you, I'd get them in, like Andrew said. Andrew said, get the x and y on the same side. Take over. Go get it. Either eliminate the x's or eliminate the y's. I don't care. I just care that you get the right answer.
I'm just checking.
Good. If you have it, show me. Where's y? Where's your y then? You got x and 1, right? Where's y? Something's wrong. I don't know what's wrong. So what did you do? Oh, you left it in slope-intercept form, right? Okay, so y equals negative 3x plus 6, right? Then you made this negative y by multiplying negative y, which would make this positive 3x, which would make this, what is that? No, it was negative 3x plus 6, right? And then when you multiply by negative 1, you get negative 3x, and this should be a minus 6, right? You know, add down, you get 0 equals 2x. That's minus 6, so that'd be a negative 2, 2x minus 2. Hang on. You made this 0 equals, right? This is 3x equal 1, that's 2x. 4 minus 6 is a negative 2. You have to solve that.
Is x 9?
X is not 9, no. Okay, hey Paige, since you said that to me, will you just tell me this? Which variable did you choose to eliminate? Y, okay. How did you get the y's to be opposite?
No, I subtracted the 4x and I solved for y. I don't know.
Subtracting the 4x. I don't get what you're saying. Are you
Like
ready?
I added the 5 over to the other side.
The 5? I don't even see a 5.
Right to the wrong.
Where's the 5? I don't see a 5. Okay. Hey guys, help me help you. So what did you multiply by? Gabe, put your phone away. Alicia, help me. What'd you multiply by? Don't know. Hey, look, I got a 1y, I got a 1y. Let's make one of them negative 1y. How? Multiply by negative 1. Yeah. Hey guys, if you multiply by -1, this will give you -3x, this will give you -y, and this will give you -6. Draw your line, and then you just kind of scribble that up. Don't look at that anymore. Once you change the equation, don't look anymore. All right. So you got a 1x and -3x makes -2x. The y's do what? They're out. The number 4, take away 6 is -2. Divide by what?
-2.
Yeah, -2, you get what?
1.
1. The answer for x was 1, guys. 1, comma, something. Put the 1 back into anything you want. Go to the originals. Where would you like to put the 1? The what?
3x.
Hey, how about if I put it in the original? Y equals 4 minus x. Can I do that? Yeah? Okay. Y equals 4 minus x. X is 1. Look. What's the answer? 1, 3. It is 1, 3. Okay. Last one. I don't have to tell you what to do. Just do it. If you get it right, I will give you your homework. Anybody got it yet? Okay, that is what we call the system, but what's the answer?
Like, no solution. We did all of them.
So now, you want this. This is over. Or you want the y. So
So you can
if
get
you want those to go over, what could you make? What's a number that 3 and 6? Well, 2 goes into 6 and 2 goes into 3. I'm looking for a number they go into. 3 goes into 3, 6 goes into 3. When I say numbers they go in, it's 3. What does a 6 go into? 6, 12, 18, 24. What does a 3 go into? 3, 6, 9, 12. What do they both go into? Oh, okay. So if you want to make that one 12x, what do you multiply? 12 times 3 is 36. I think you're going way too big. I mean, you can do that, but you're just making more work for yourself. I would say if you want that to be 12x, hold 3 times 4 is 12. So put a 4 up there, and then wrap it in parentheses, the whole thing. Yep, so 4 up there, yep. 4 times this is 12x. 4 times this is 8y. Or 12 or 4 times 10 is. Okay,
so
now look, you got that.
you just multiply
Get that.
the first one,
Negative.
the equation for
By multiplying by 2. But 2 makes it 12. You want it to be negative. There you go. And then once you write that down, then just add the 2 together.
Then how
You did what?
still be
Times 2? Yes.
12x.
Oh,
We do
oh.
4.
Hang on. I think you want to multiply
Oh,
by negative. Because what would negative 2 make? Negative 4. That's positive 4. There, you got opposite. I think I would multiply by negative 2. Okay. And then, of course, this one too, right? All right. This one's a little weird, isn't it?
Is that
Okay.
right?
I don't remember that answer, but hang on.
Because I multiplied the top one by
Yep.
-2.
And you got that, and then you add it down, and you got 0, 0. And -2 times this would be -20. See, that's what I didn't remember. It's -5. Okay, but what does that mean, Jonas? Last week, what did it mean on the quiz?
Oh, no answer.
Yeah, no, that's it. Okay, quick, here we go. Jenna, read me those two equations.
3x plus 2y
Equals 20?
10.
Oh, 10, okay. And then what's the other one?
6x plus 4y
Say again. 15, okay. All right, so guys, here's your system. You just have to get opposites. So either you make both of those what? The x's. You can make one of them 6x, which it is. How about the other one? Make it what? Negative 6x. Or wait a minute. Here's a 4y. How do you make that negative 4y? Multiply by what? Negative 2. There you go. Got it. Okay. So guys, watch. I would just multiply by negative 2 here. And I would multiply by negative 2 here and get what? Negative 6x. Negative 4y. Negative 20. Draw your line. And ignore this one. Don't even look anymore. Okay, what's 6x? Take away 6x. 0 plus 4y, take away 4y. 0 equals what? Negative 5. So basically, doesn't it say this? Your x's and y's disappear just like last week. And you got what? You got a false statement. False means what? Not true. Okay, yep, it does mean not true. But when it comes to a system, it means you have two lines that what? Two lines that they're parallel, but they don't touch. So what's the answer to this one? There is no answer to this problem, right? There you go. The answer was, there is no answer. What if that would have said 0 equals 0? True? You'd say infinite amount of zeros, right? Okay, there you go. The elimination method. There you go. Jonas, are you good?
Yep.
Yeah. Okay. All right, you got 8 minutes, or roughly about that time. I don't know, in 8 minutes, I think you can hammer out at least maybe 4 of these, maybe. It's about a couple minutes per problem. When is